teachers, and hello everyone. Today I would like to presentation about topic summary lesson which we have joined teaching program from lecturers Indonesia. And my name is Hong Mani Ratana.
My name is Hao Kim.
My name is Han Kim Han.
My name is Hin Supan.
And my name is Kha Sok Hai.
And my name is Hai Ming Kuang. Now my team would like to presentation about the two topics. The first topic is primitive data type and the second topic is hashing. Okay. Now we will explain the first topic, primitive data type and abstract data type. Now we will have the interview. I would like to explain to you about the primitive data type in C++, and Kim Ha will explain to you about the abstract data type or ADT and concept of abstraction. And about the Sokin, explain to you about the example of the ADT. The first, primitive data type in C++. Primitive data type in C++ built-in or predefined data type in C++ that would be used by directly declared to a variable. Example of primitive data type like Boolean, integer, short, integer, long, or char character like char, floating point like float or double. The next point, we have signed vs unsigned. The unsigned number of 8 bits can hold value between 0 to 255. It's okay as long as you only need positive number. How about negative number? Consider using first bit of the memory state to sign the positive or negative. 1 become negative number and 0 become positive number. And welcome to my friend Kim Ha.
Okay, my name is Kim Ha. I am going to explain about abstract data type and the concept of abstraction. An abstract data type is a set of objects together with a set of operations. The ADT separate two related things. The first one is the specification. It is what kind of thing that we're working on and what operation can be performed on it. And the other one is the implementation. It is how the thing and its operation are actually implemented. For example, the list ADT below. Suppose we need an order collection of item of some element type, ID, item name. So we need to think that the user will use the data and do some operation on it. So what operation can we think of? So initially, we need to think that how the item represented in it internally in the list. And the other step is when we perform the add operation, how do the list sort the data accordingly? And the last one, we need to know that do user need to know what algorithm used for sorting data? So moving to another part, why ADTs? Actually, the user don't want to know how the operation implemented. They only want to know about what the operation do. So we need to design a software that work as specified, easy to understand and modify, reasonably efficient, and the most important thing is maintainable. Therefore, we need some level of abstraction so that the user can use the data structure effectively. So what is abstraction? Generally, abstraction means omitting or hiding some low-level detail of a software and exposing only the high-level operation to be used by the user. So moving to another part is the concept of abstraction. The first concept is modularity. It is a concept of dividing system into module or component, each of which individually designed, implemented, and tested. And the module must be self-explained enough and can be reused to the other system. The second concept is encapsulation. The module is responsible to their own internal behavior, separated with the other part of the system. The third concept is information hiding. It is a concept of hiding detail of our module implementation. For example, like algorithm use internal variable from the rest of the system, and changing the internal operation will not affect the rest of the system. The last concept is separation of concern. One module only responsible for its operation rather than responsible to the other module.
And welcome to Sokin. Thank you, Kim Ha. And I'm going to talk about an example of ADTs. It will cover the linked list, stack, queue, trees, graph, and hashing, and also the common operation of ADT. insert, delete, getting value, checking value, traversing, searching, sorting, ordering. Okay. And first, let's talk about the linked list. Linked list is connected to each other with a single direction. Linked list can link to one other node. Linked list is different from array because the array is whole limited number of elements, but linked list could have unlimited data. Linked list and when it is become null, and the operation of the linked list is insertion, deletion, and traversing. Next, we have stack and queue. Stack is the container of objects that are inserted and removed according to LIFO. That means last in, first out. For example, like the table on the left, we add the data A, B, C, and D. If we want to delete or remove that data, we need to remove the last insert. That means the data E. And we use operation push to insert and pop to delete. And queue is the same as stack, but it uses FIFO. That means first in, first out. And it has operation in queue and dequeue. Okay. Next one is the trees. The trees can link to more nodes. As you can see, the data A is linked to B and C, and B and C has D and F, and C have F. That means B has two elements that we call the line connection between B and D is H. And the operation of the trees is insertion, deletion, and traversing. And the graph is the same as tree, but it has the different way to insert the data. Like we can insert A, B, C, and we can go to E, or we go to A, D, and D directly. And the operation of this graph is as same as the tree. The last one is hash table. Hash table use mathematical hash function to compute the index into the table by hashing function. And the operation of this hash table is insertion, deletion, and searching.
And now I'm going to talk about the hashing. In the overview, we have hashing function that are described by me, and collision resolution by Moniratana, and determining the key to hash by Panya. And what is hashing? Hashing is a technique or process of mapping keys or values into the hash table by using hash function. And about hashing, the idea of hashing is to distribute entries, key or value pair uniformly across an array. In hashing, right key are converted into small keys by using hash functions. The values are then stored in data structure called hash table. The hash function composes an index that suggests where an entry can be found or inserted in hash table. And next, for hash function, is any function that can be used to map data of arbitrary size to fixed size. To follow this function, we use this formula: hk equal to k multi size, where k is key and t size is table or array size. Let's move on to Muradana.
So what is hash collusion? So the hash collusion is a condition in which two or more hash indexes, which are calculated from the hash function, have the same values. So there's two ways to solve hash collusion problem. First one is open addressing, and second one is separate chaining. So in here's opening addressing. So the main point of concept here is they are use the best formula h of k equal to k modulo to t size. So if we are going to use a linear probing algorithm, they just input number consequently depend on how many times they have faced duplicate hash number or collusion. Imagine if num has index number 1 storing key values of 50, and have another key value occurring with hash index number 1, they just add +1 based on each bucket. So the secondly, they just add multiple number when they duplicate number. If they face hash index 2 times, they just calculate 2 multiple 2. And thirdly, the ball hashing algorithm, they are using h of k equal to k modulo to t psi. Whenever they meet collusion of number, it will be change the number in the bucket. Example, if hash index number 1 have occurring collusion 5 times, we have to using h of k equal to h of k plus 5 multiple ha of k modulo to t psi. And the next slide is separating chaining. So separating chaining is using the same method of linked list. They will not divided the number after they got collusion. They storing the key values continuously. That's all. Moving to Panya.
Okay, next we will talk about determining the key to hash. To determine the key to hash, we have a few methods to determine the key. There are folding, extraction, reduct transformation, string-based key hashing. Now let's take a look at the folding method. In this method, the key is defined to several paths. These paths are combined or fold in a certain way. For example, if we have the social identity number like 1, 2, 3, 4, 5, 6, 7, 8, 9, we can divide it into 3 paths, as you can see, and then we can add it together, and it will give other new result like 1368. And after that, we can use the hash function to determine the hash index by modulo with t psi. And the next, we can fold the number by reverse order. In this path, we can divide it into 3 paths like before, but the second path is reversed. So it will be 1, 2, 3, 6, 5, 4, 7, 8, 9. And the result will be 1568, and the hash index will be that the new result number modulo with t psi. Next, we will talk about the separate chaining method. In this method, we use only some part of the key to compute the hash index. For example, if we have student ID 2015 10 10 23. For generally, the first 6 digits refer to the year of the student or the department. So the only 4 last digits that refer to identify the student. So we can use the last 4 digits to compute the hash index by modulo with t psi. Another method is extracting several first and last digits of number, then combined together by using folding technique. For example, social identity number 1, 2, 3, 4, 5, 6, 7, 8, 9. We can use the 3 first digit and last 3 digits to determine the key. So it will be 912 as the new result by adding first 3 digits and last 3 digits together, and modulo t psi we will get the hash index. And the next method is radical transformation, that we can use the number to transform into another number base. For example, if we have the ID number 3, 4, 5 in base 10, we can transform this key to the base 9, but we treat it as base 10. So the hash index will be 4, 2, 3 in base 9, but we treat it in base 10 modulo t psi. And the last method is string-based key hashing. A string can be transformed into an integer by converting a character into integer and add together by but in this method it will increase the collision. For example, suppose that a equals 1, b equals 2, and c equals 3. So the hash index of ABC and CBA are equal to 6 modulo t psi. So it will increase the collision. So in this part we will use a method that's called polynomial rolling hash function that can minimize the effect. And this method, I use the formula like you can see in screen, and in this s equal to the alphabet or the string, and the p is equal to the prime number that roughly equal to the number of characters in the input alphabet. We only using lowercase letters, so the p will be equal to 31 is a good choice. But if you're using lowercase and uppercase, the p equal to 51 is the better choice. Like in this code, hash index of the string hello will be 8 multiple like in the screen, and the result of the calculation will be modulo with t sign, and we get the hash index. Okay, thank you for listening.